Hey, in this video I'm going to show you how you can use GetBlock's Yellowstone gRPC in order to track Pump.fun Token mints in real time. And this guide is available at the GetBlock docs, which is at docs.getblock.io. So to get started, I'm going to show you what we're going to be building. And as you can see, I'm just going to open up my terminal. We're going to be building a Pump.fun Token mint monitor. And this mint monitor is going to track new Pump.fun Token mints as soon as they're minted. And you can see we get the name, we get the symbol, we get the mint, creator, bonding address, metadata, signature, and a whole lot more data about the transactions with links to all the explorer. So now you can see we've got a couple of token mints, and all of this is basically running in real time. So as soon as there is a mint, you're gonna see a message right here on our terminal, and we're gonna get all the details about that particular Pump.fun token. So we're gonna see how you can actually build this out and how easy it is for you to actually integrate GetBlock's Yellowstone gRPC in order to build this out. So to get started, we can just come over to the docs, and you can see here we've got a brief overview comparing various methods in which you could actually receive these Pump.fun token mints. If you had to do traditional RPC polling, you're going to get constant delays with high API requests and resource usage. And in comparison to traditional RPC, you could try WebSockets, but again, you're going to get 1 to 3 second delays, and the server basically pushes updates whenever available. Whereas Yellowstone gRPC, as you can see, is the best solution with very low latency and bidirectional streaming. You're going to get the token mints as soon as they happen on chain. So coming to why GetBlock's Yellowstone gRPC, GetBlock basically provides you access to this particular plugin, and you get extremely low latency, and you can have efficient filtering. So you can just subscribe to the specific programs and accounts you need, so you don't need to process all the on-chain activity. And then you've got bidirectional streaming, which means that you've got a single persistent connection, which means you don't need to keep polling. And similarly, you don't need any infrastructure because GetBlock handles everything under the hood for you. And integrating this is really simple as well. As you can see, we're going to walk through the complete code that basically powers our token mint monitor, and we're going to see how everything actually ties in together. So in this guide, we're going to completely go over from scratch how you can set up your GetBlock Yellowstone endpoint and actually get started with building this. So to get started, what you can actually do is you can basically go to the repository here. So this is GetBlock.io guides, and you will find this link as well. And as soon as you're here, you can see this particular repo contains all the guides that you basically see over here. And for our particular guide, we're going to go into the Pump.fun token mint monitor. So this is what we're interested in, and you can see we've got all the code right here. So to get started, you can just clone this. So I'm just going to copy this and copy the URL, and then you can open up your terminal. So I'm just going to probably open up a new terminal. Okay, and I'm just going to go into desktop. So now you can see we have put in the yep. So now we have cloned it, and let's cd into it. So that's it. So once you have done this, you're basically in the folder, and you can basically see we have got all the guides that's present right here. So the guide we are particularly interested in now is the Pump.fun token monitor. So that's what I'm going to do. I'm going to go into the Pump.fun token mint monitor. That's it. And you're all set. So now you can basically open up the complete code on an IDE of your choice. So I'm just going to open this up on cursor with this command, and this is going to open up my cursor IDE. So there we go. So now you can see we have got all of our code which is necessary for running this tutorial. So I'm just going to minimize these for now, and you can see we've got the example env. This is where you put in your GetBlock access token. You've got the Pump.fun monitor.js file, and this particular file, so let me just close this. Okay, so you can see we've got the Pump.fun monitor.js file. So this is the main file that's used for actually tracking the particular address and subscribing whenever you receive a particular mint that happens on chain. And as you can see, we've got a couple of functions over here. We're going to walk through the entire code, but I'm just going to give you a quick overview right now. You've got a package.json file which contains all the necessary dependencies, and you've got a gitignore which is just necessary for you to not commit the unnecessary files to GitHub. So now that we're all set, we can actually open up the terminal right here. So I'm just going to open up the terminal in cursor, and the first thing I'm going to do is basically go over to my docs and show you what all are the prerequisites before you even go into actually running this code. So as you can see, the prerequisites are you've got to have Node.js and npm installed. You need a basic knowledge of JavaScript in order to actually run this code, and you need a GetBlock account with a dedicated Solana node subscription for Yellowstone gRPC access. So in order to get everything set up, you can basically just go through this particular guide which says how you can set up your GetBlock Yellowstone endpoint. And you can also do another thing, which is go into add-ons and just check out this quick start guide. So this quick start guide actually shows you how you can actually step by step go into GetBlock and deploy a dedicated Solana node. And once you've done everything, you can see you've got to select the Yellowstone gRPC. And once the endpoint is basically live, you're going to get this particular URL. So this particular URL is going to correspond to the region of where you have deployed your dedicated node, and the token basically points to the GetBlock access token, which is what you're going to use for retrieving or accessing on-chain data. So now as you can see, you can subscribe to various data streams. You've got a couple of code examples over here as well, and this is basically going to show you just some examples how you can quickly get started with your Yellowstone gRPC API. So once you've got your node all set up, so you can just go back to the guide, and as you can see, it shows you again the same steps how to set up the GetBlock Yellowstone endpoint. And first step is to deploy the dedicated node. Once you have deployed that, you need to enable the Yellowstone gRPC add-on. And once you have completed that, you need to generate an access token. So that access token is what's going to go into the env as well. And finally, once you have done that, you will receive a URL that looks something like this. So you're going to get the go.getblock.asia or whichever region you're using, followed by your access token. That's going to point to your Solana dedicated node, which lets you ultimately use them at the Yellowstone service. So now that we have cloned everything, we're all kind of set up. So the next step for us is basically to do npm install. Because we've already got everything in the package JSON, it's going to be fairly simple. So all I'm going to do now is I'm just going to run npm install, and this should actually install everything based on the dependencies that you see right here. So now you can see as soon as it's installed, you've got the node modules right here with all of the packages that we need. And the next step for us as we follow this guide is to actually start building this monitor. So I'm going to walk you through the existing code that we have got right after cloning it. You could go through this step by step as well. So I'm just going to give you a quick walkthrough of the code. And as you can see, let me just close this. Yeah. So these are some of the initial dependencies that you basically need in order to run this program. So you can see we are importing from the Triton 1 Yellowstone gRPC package, which is necessary for us to talk to the Yellowstone service. And then we're importing the base 58, which is basically necessary for us to do some operations and in terms of the address and decode the actual signatures, etc. And then you've got the config from .env, which is basically what we're going to use in order to retrieve the access token from the env file. So once you have basically got this all set up, we are using config in order to actually pull in the env credentials from our env file. So you can see we've got the .env.example. So you actually have to create a .env file here, and with this .env file, you're going to be putting in this particular thing, the token, and you're going to replace it with your actual token. So I'm just going to leave it like this for now, but when we run it, you'll see that we have to change it. So now you can see we've got the endpoint set up, we've got the token which is reading from the env as well, and this is the Pump.fun program that we're actually tracking. So if you actually open this up on the Explorer, I've already got it here, you will be able to actually see this is the program analytics, and you can see all the signatures. So all the transactions which are happening related to this program show up over here, and we're actually tracking a very specific instruction type, which is basically for creating the token. So that is basically present on our code as well. So if we go back to our code, you can basically see we're tracking the create discriminator, and when there is basically a token mint created, it's going to actually be visible on chain in this transaction explorer. So coming to the next step for us is to actually start building the monitor, and you can see we have added the get block configuration as well. And the Pump.fun constants basically identify the Pump.fun program ID on Solana, and the create discriminator is basically 8-byte identifier which marks the token creation instructions. So that's what we see right here. So this is basically uh, converting this particular function global create, and it's going to actually hash this, and we're gonna get this discriminator. So the next step is to just add some statistics tracking, so that at the end, while you run this, you're going to see how many mints were actually tracked and everything like that. So the next step is to actually see the data parser functions, and the data parser functions are basically for parsing in the raw data that we receive. And as you can see, we have a string decoder that's going to actually retrieve the string data out of the particular buffer and offset. And as you can see, Pump.fun stores strings as 4 bytes for length followed by the actual string data. And this 4 bytes for length is basically a way for the Solana program to understand and fetch these files. And as you can see, we've got 4 bytes for length, and the string data itself, which is followed by the 4 bytes. And this function is going to give us both of these things in a very easy format that we can use in our program. And the next step is to add the instruction parser. And the instruction parser, if you can see, basically reads the token metadata from Pump.fun instruction data format. So the way the instructions are or the data within the instructions are actually organized is that you've got the first 8 bytes to be the discriminator, and that's only identifying a particular thing as a create instruction, because we want to filter out only token mints. So we're going to just filter out the create type of instruction, like you can see right here. So that's the ones we are interested in. And the next thing is basically going to give us the token name, the symbol, and the metadata URI. So the function starts at byte 8 and reads each string one by one using the decode string helper function. So you've got the decode string helper, and this is the main function that's actually going to use the decode string function in order to get out all the necessary fields that we require. So if you go back to our code, you will be able to see it right here. We've got the parse create instruction here, and we've also got the decode string function right here. So the next function you can see right here is extracting accounts. So right now what we're actually doing is we're just creating the utility functions, and these utility functions is what is going to help our code actually display the Pump.fun token mints, as you can see right here, as soon as it happens in a very neat and clean format. So now that we have seen the instruction parser, the next step is the account address extractor. And what this is going to do is, you can see it returns the mint, the bonding curve, and the creator. So it's going to extract the 3 key addresses from this particular instruction. So you've got to pass the transaction and instruction index, and you can see that it's going to get the transaction message, the instruction itself, the account keys, and the account indices, which are basically used for retrieving the data that we basically need. So that's what we have actually implemented in our code as well. So the extract accounts function basically is responsible for getting the fields that we need. And you can see that these are defined by the Pump.fun program structure. So if you go into the Explorer and actually try to look up the program, you will be able to see that this is how it's actually getting the addresses that we basically require. So the next step after this is to add the instruction verifier, and this is necessary because you want to actually verify that the instruction calling the is calling the Pump.fun program and not another program, and the first 8 bytes should actually match the create discriminator itself. So you can see this is the function, it's create instruction, and this is going to check basically whether or not it's the Pump.fun program that it's interacting with, and also whether it is the create instruction which we are interested in. So these are the two main things that this function is going to check. And if you see the next function, it's to actually display that in a very readable format, and that's what you see in the output as well. Like, this particular format comes from this function. So the display token mint function is going to basically uh, display like all the things like the statistics, the token data, the token symbol, the token mint, the creator, bonding curve, essentially everything you might be interested in from like tracking a Pump.fun token mint in real time perspective, you're going to get visible to you in the terminal. So coming to the next step is basically to build the main monitor function, and this is where the core parts of the Yellowstone gRPC service etc start. And as you can see, this particular main monitor function, we're going to break it down into smaller parts so that it's easier for us to understand. But essentially, as you can see right here, here's the monitor pump.fun mints. The first step is to basically connect to GetBlock. So that's what you're going to see. We're going to create a Yellowstone client, and that's created with the endpoint token. And you can see that the stream is going to subscribe to the client. So once you've created a client connection and you've opened a bidirectional streaming, you're going to actually configure the subscription so that we only receive certain things that we are interested in. So if you go back to the code, you can see right here that this is the part where we actually configure the subscription details. So if you see here, you're going to only tell GetBlock that you want transactions with the Pump.fun program, and we are also going to set the commitment level. And as you can see, the commitment level here is set to confirmed, which means that you're going to get confirmed transactions only. So that's what we're interested in. You could set this and play around with different commitment levels to actually receive transactions probably before they're confirmed as well. But this is what we're going with in this tutorial. So the next step is to actually handle the incoming data. So as you can see, we have got a stream.on, and this is going to actually subscribe and receive notifications as soon as basically there is a token mint happening. And over here, if you see, the incoming data is going to be parsed first thing. And apart from just parsing it, we're going to receive the transaction, we're going to get the signature, we're going to get the slot, the transaction message, account keys, and instruction. And this processes each message from GetBlock and responds to keep alive pings and extracts the transaction data that we're actually interested in. So now that you've gotten like all the transaction data, the next step for you is to actually process these instructions, which means that we have got to use the utility functions that we have created just above. So you want to extract the accounts, you want to extract the token data, the addresses, etc. And that's what you're going to actually do in this function. So for every instruction that actually meets a criteria, we're going to process it. And if you see what is actually happening, we are parsing the create instruction and we're getting the metadata. And after you've done that, you're extracting the accounts. And once you've done that, you're basically displaying the token mint on the terminal. So once you've parsed it, we are basically displaying it. And this basically checks if it's a create, it parses the metadata, extracts the address, and displays the results. So if you go to our code, you can see right here that that's what we have also implemented over here. So this is the part where you process the instruction and you're checking each instruction in the transaction. And if it's basically a create instruction, you're going to actually use the utility functions to retrieve the accounts, the addresses, the token metadata, etc. And we're going to essentially display the new token. So this is going to create the call the display token mint function, and it's actually going to display the token for you. So that's it in terms of the monitor Pump.fun mints function. And the next step is to probably just handle some errors if in case there are any. So that's what we have the catch block for. So as soon as there is basically any error happening, we're going to basically receive notifications. So as you can see, we're again putting an outer stream.on error, and this is going to again basically show the errors on our terminal in case there's any. And finally, if you see, you have to send the request. So this is what is going to send the request with the initial subscription monitoring stuff, etc. And only that's going to let us basically send a subscription request to GetBlock and confirm that the connection is active. So you can see that this completes the monitor Pump.fun mints function, and everything is basically part of this one function in the Pump.fun monitor.js file. So you can see that stream.write is going to actually write the subscription to the GetBlock Yellowstone gRPC service, and we're going to have everything set. So that's basically it in terms of the monitor Pump.fun mints function. So this is like the main function you need to focus on because it's interacting with the GetBlock Yellowstone gRPC service along with our token, and it's also going to call all the utility functions we developed above in order to retrieve all that data. So that's what we've seen right now, and as you can see, the subscription will be active monitoring the blockchain. And finally, you've got the main function. So the main function is going to actually add the execution code to your monitor. So as you can see, we're also having a automatic restart in case it crashes. So that's why we have a set timeout, and again we're running main function, so it's going to run continuously. So This process.on SIGINT is basically going to ensure that we show final statistics before the shutdown. Like right after you try to end the program with a control C, this is going to show you all of the statistics and ultimately show you how many tokens we have tracked. So if you want to just test this out, I have the terminal running here. So you can see the Pump.fun mints are coming in real time. And when I do click control C, you can see we've got the shutting down message and it shows us the total mints detected and the uptime. So that's essentially what this code is doing as well. So finally, that now that we have completed a complete walkthrough of our code, we can actually try running this project and see the output as well. So to do that, what you're going to do is you can just open your cursor or your IDE and essentially put in your actual token that you've obtained onto your IDE itself. So I'm just going to do that now. Alright, so now I'm just going to open up my cursor. I'm not going to show you my env because I've added up the credential that's needed for basically tracking the Pump.fun mints. And essentially, once I've added the Yellowstone gRPC credential access token, I should be able to run this and actually see the output. So what I'm going to do is I'm just going to run the node Pump.fun monitor.js file, and I'm just going to use node to do that. And as you can see, .env is actually injecting the env and we're all sorted. So as soon as there is a token mint happening, you're going to be able to see that particular mint happening right here. And as we saw from this example, you can see and receive all of these token mints in real time. So we have to wait for a while if you want to see these token mints, but essentially this is how you're going to receive these token mints with the name, symbol, mint, and you're going to get links to the explorer, the transaction, and the creator. And all of these again will show you everything about this particular token. So as you can see, this is one token that it's showing you, etc. And that's just how the entire process works. So now as you can see, whenever a token appears, it's going to display it like this. So I'm just going to check the terminal. If in case there is something, you will be able to see it here. But if not, you can basically check out the when a token appears, it's going to essentially look like this. And you can also check out troubleshooting in case you're not able to see the token. This might be some of the reasons. You might have some connection issues. You need to ensure that the endpoint token are created. If the tokens aren't showing, essentially it might just be that the tokens aren't minted right now. So you've got to be patient. So as soon as the token is created, you are going to receive that particular message. And you can also try commitment level.process. So you're going to get faster updates as soon as it's basically just processed. So these are some security best practices. So you've got to use the env file in order to actually store your GetBlock access token. So that's what we see right here and what we've done as well. So you can use .env in order to actually securely store your access token and actually read them within your main code. And in conclusion, this is what we have actually built. We have created a Pump.fun token mint tracker using GetBlock's Yellowstone gRPC service. And we have basically seen how you can configure the utility functions that are necessary for our code, how you can actually build the main monitor function and the various parts that are involved with it, and essentially how you can receive new token mints as soon as they happen on chain. So looks like we've got our first token mint here. So as you can see, let me just pull up the terminal a bit more. So you can see we've got the name, we've got the symbol, the mint, the creator, bonding. And if you actually go to this particular transaction, and I'm just going to open this up, and you will be able to see this happened just 19 seconds ago. And this is essentially how you can receive new token creation instructions as soon as they happen on chain instantly with GetBlock Yellowstone gRPC. So that's it for this video, and if you have any questions, you can definitely check out the guide and also the code base which is available at GitHub. Thank you.